Welcome back. In this video, we are going to be discussing the concept of inductive effect. Now, inductive effect is one of the consequences of bond polarization. I've discussed bond polarization in my former video. I'm going to link it in the description below. Now, inductive effect is basically a push or pull on electron that happens on a sigma bond due to differences in electronegativity values. We can also define it as the transmission of charges across sigma bonds in a carbon-to-carbon chain. Now, let us clarify that. We remember that covalent bonds are formed due to equal or unequal sharing of electrons between bonding non-metals that are bonding. And in organic chemistry, we'll be discussing about carbon, right? So when carbon forms bonds with other atoms, it forms a covalent bond. Now, there could be unequal sharing or equal sharing of electrons. Now, what do I mean? Consider this molecule. This is 1, 2, 3, 4, 5. This is pentane molecule. Okay, let's not use the skeleton structure. Let's use the actual structure. Now, I have this. Now, this is pentane, the pentane molecule. Now, in this molecule, there appears to be equal sharing. There appear not to be any form of polarization in this molecule. Why? Because there is equal sharing of electrons between these bonding atoms. And why is there equal sharing of electrons? What do I mean by that? It is because of their almost equal electronegativity values. Remember, we talked about the fact that electronegativity means the ability to attract electrons. So each of these bonding atoms have almost equal ability to attract electrons. Now, we said the difference in electronegativity values will be significant if it is greater than or equal to 0.5. But whenever it is less than 0.5, the electronegative value difference will be insignificant and hence will not significantly polarize a bond, isn't it? So, and according to the Pauling scale, we have that the electronegative value of carbon is 2.5, while the electronegativity value of hydrogen is 2.1. So, and this difference is equal to what? 0.4, which is what? Insignificant. Hence, there is equal sharing, equal distribution of electrons among the bonding atoms. No atom is enjoying the electrons than its counterparts. Is that okay? Now, and of course, even carbon to carbon, this bond is also non-polarized. Now, what would happen if I were to bring about polarization? What would happen if I were to add a substance known as an organogen? Remember in our video, we talked about the fact that an organogen is a substance that is capable of polarizing a bond. Now, an organogen is basically a substance that has a high electronegativity value or a significantly low electronegativity value. So in this case, let us in fact add something like fluorine or chlorine. Let's add fluorine, for example. Now, if fluorine be added here, now fluorine is called an organogen. Now, what will begin to happen in this molecule? Now, it is notable experimentally. Now, inductive effect is an effect that has been verified experimentally. Now, it has been noticed experimentally that the tilt of electron will be more towards fluorine. And we talked about this in bond polarization. Now, think of it as you and your friend were to share food. Now, because he had maybe physical advantage over you, he can pull more of the food to himself. He will eat more of the food. For example, it was a tug of war of collecting food, for example. He would collect more because he had some advantage over you, and you will be feeling, so you'll begin to feel food deficient while you'll be feeling food sufficient, isn't it? The same way here, there's going to be a pull on electrons, and fluorine having a whooping electronegative value of 4, greater than carbon of 2.5, really greater than carbon of 2.5, will feel what? Electron sufficient. It means that the electrons will be more abundant. The electron cloud now, electron density, is going to be more towards its own side. The pull on electron is going to be more, electron density is going to pull towards a side higher than electron density will be towards that side, towards the side of carbon. So, and because of that, we say that a positive charge is induced on the carbon, while a negative charge, a partial charge now, a partial negative charge is induced. Now, why is it a partial? We said in bulk polarization that it is partial because there is no complete abstraction. There is no complete or total abstraction of the electrons. It is only a feeling within the cloud that they are, they are going to be sharing an electron cloud, isn't it? So their electrons are resident here, for example. Here they'll be sharing 1, 1. So electrons, these two electrons are resident here. If this was fluorine orbital and this was chlorine orbital, carbon orbital, electrons will be tilting more towards fluorine than will tilt towards carbon. So electron, this guy will be enjoying more of the residence of the electron cloud. And that is what is known as what? The inductive effect. Why? Because positive charges will now be induced now across all of this chain. Now listen to you understand now. When positive charge is induced here, what happens here? This guy begins to feel more electron deficient, isn't it? So because it is now feeling more electron deficient, it becomes more electronegative, slightly more electronegative than this guy. Hence, this guy, relative to this guy, is going to also become what? Positively charged, isn't it? And relative to this guy also, this also what? Become what? Positive charge. Now, the effect does not continue throughout the chain, because experimentally it has been proven that once after the third carbon, that effect begins to fade. It becomes almost almost insignificant. That it doesn't. It is it is just insignificant that it cannot be measured again. That is not effective on the fourth carbon. Is that okay? So here we represent this by drawing 3 arrows to represent the strength. That it is very strong towards here. So that electrons are pulled more towards this guy, and relative to this guy becomes a slightly electronegative. Now, more electronegative than this. The reason that's why it's called inductive. That is positive charges are induced. Now, why is positive charge induced? On this guy, relative to this guy is more electronegative now than this guy. So because of that, this guy will become positively charged, and relative to this guy will be enjoying more of the pull. So this guy relative to this guy will be electronegative. But across the chain, we put positive charge simply because the pull is always more towards the fluorine. Do you understand? So, and as long as the fluorine is there, the inductive effect is going to take place. Is that okay? And so we said the electron density is towards there. So this is going to experience a lower inductive effect than this guy is experiencing, and this guy is going to experience a lower inductive effect than this guy, second carbon, experienced. Now, you see the pull of the electron is always towards what? The electronegative carbon. And because of that, we call this guy a negative I effect, a negative I group. So the effect is called negative I effect, negative inductive effect. And why is it negative inductive effect? Because it reduces our electron cloud. It reduces electron density in the chain. Because electron density will not be towards one side. Do you understand? So it reduces it. So because it reduces electron density in this chain and makes it unstable towards one side, it is called a negative I effect. Now there is the reverse, which is called a positive I effect. A positive I effect is the one that increases electron cloud or electron density in our chain. So if it increases the electron density of the system, it's going to be called a positive I group. If it reduces the electron density of the system, it's going to be called a negative I group. And these are the types of inductive effect. We said that now, these ones are organogens that reduce the electron density in our system. So examples are all of our halides, of our halogens. We have fluorine, we have chlorine, we have bromine, We have iodine. Now we also have OH group. Is that okay? Now all of these guys are what? Electron. These guys are negative I groups. And these guys are positive I groups. Which guys? I mean, the positive I groups, we include any substance with a negative charge. So for example, if we have this guy, oxygen with a negative charge, it's going to be what? A positive I group. Why? Because it is electron sufficient here. It's going to be donating electron, it's going to donate its electron, push electron into into the system. So the same way, sulfur with a negative charge is also going to push electron into our system. Is that okay? Now, and also we have other positive I groups, the methyl, and so a methyl group, the methyl group is going to be lower in effect than the. We're going to talk about this in a jiffy, but let's just talk about the fact that all of these alkyl groups, they are what? They are electron donating groups. So, and the higher the carbon, the number of carbon, the higher their positive I effect. Now, let's go on to talking about the characteristics of inductive effect. The characteristics of inductive effect. Number one is the fact that the direction of pull of electron is certain. The direction is what? Is certain. I hope. The direction of pull of electron is what? Is certain. And is it capturing? Now, the direction of pull of electron is what? Is certain. And the second thing is that, and why is it certain? Why is it certain? Because the direction of pull of electron is what? Always towards the what? The more electronegative element, which is called the organogen. So the direction is certain. The direction is certain. And now so the direction is towards what? The more electronegative elements. Now the second characteristic is that there is no, I talked about the fact that there is no complete abstraction. So there is no removal of the electron. It's only that the electron cloud are tilting more towards what? The electronegative element. Now the other thing is that as far as this fluorine remains in the chain, as long as it remains in the chain, the inductive effect persists. So we say it's what? A permanent effect. It is only, the inductive effect only stops when the organogen is removed. So without the organogen leaving the group, the effect is what? Constant. It is permanent. Then the fourth one is that now it is measurable. It is what? Measurable. The magnitude of the inductive effect, the magnitude of the inductive effect is measurable experimentally. All right, it can be determined experimentally. All right, the other thing is that now this carbon, the first carbon that experiences the highest inductive effect is called the alpha carbon, and the hydrogens attached to them are called the alpha hydrogen. This is called the beta carbon, and these guys are called the beta hydrogen, and this is called the gamma carbon, and these guys are called the gamma hydrogen. Is that okay? So, and it has been noticed that these hydrogens, the alpha hydrogen becomes acidic, hence can be easily abstracted. See, recall that the electronegativity value of carbon is 2.5, and these guys, and why hydrogen has a electronegativity value of this 2.1, while carbon has electronegativity value of this 2.5. Now, the difference was 0.4. Fluorine has a whooping 4.0. So once it induces a positive charge on this guy, relative to this guy becomes what? More electronegative. So the electronegative value will no longer be 2.5 here for this guy. It would have increased. Hence, it will pull electrons more on this guy. And then these guys become what? Acidic. And what was an acid? An electron pair acceptor. Isn't it? The Lewis acid, which is what? An electron pair acceptor. So these guys will be seeking to coordinate to other atoms, begin to look for electrons from other atoms because it's very, very electron deficient. So alpha hydrogen is what? Acidic. Is that okay? All right. So, and the other thing is that, the other characteristic is that the pool does not go beyond, never goes beyond the third carbon. So it doesn't go beyond the third carbon. The effect fades off. The effect is almost not felt after the third carbon. So now we are going to be talking about the factors affecting inductive effect. Now, what are the factors? Now, I'd like to put this down. Now, let's talk about the factors affecting inductive effect. Now, what are the factors that affect inductive effect that determines the strength of an inductive effect? Now, number one first, or whether an inductive effect will happen, is the availability of an organogen. Availability of what? A more electronegative organogen. Is that okay? So once an organogen is present, then this thing is going to happen. Inductive effect is going to happen. Now, the second factor is the strength of the electronegativity of this, the strength of the effect of the organogen. By strength, I mean the power, the electronegativity value. So, for example, consider the following atoms, the following molecules. I have this chlorine. Now, let's start with bromine, for example. Chlorine and fluorine. Now, looking at this chain, we know that this is what? Bromoethane, chloroethane, fluoroethane. Now, now, all of these bonds will what? Will experience inductive effect. This bond will experience the inductive effect. But what is the strength of the inductive effect? Now, these are exam questions. The strength of the inductive effect will be less on bromine, will be less on this chain, on this molecule, than this molecule. Is that okay? Why? Because fluorine is more electronegative, so it will have a higher inductive effect. So what does that mean? It means that bromine is less than the inductive effect on this guy will be less than the inductive effect of this guy. Why that of this guy will be less than the inductive effect on this guy? Is that okay? So the strength increases with the strength of the electronegative element that is inducing this effect. Now, the other thing is the distance. The distance from the carbon. So as the distance increases, we discover that the inductive effect diminishes rapidly. It diminishes rapidly with increasing distance. So it is what? Inversely proportional to distance. So as distance increases, it diminishes rapidly, in fact. So the other thing that affects the other factor that affects the inductive effect is the degree of carbon. So that a primary carbon will be less electronegative, will have a less inductive effect than a secondary carbon, and this will also have a less inductive effect than what? A tertiary carbon. Let me explain what that is. So, for example, a methyl group, for example, we experience a lower inductive effect than a secondary carbon, such as we have in this guy. Why? Why is now this carbon is called what? A secondary carbon. Why is it secondary? Because it's attached to another. It's attached to this is called a primary carbon, This is called a secondary carbon. This is called a secondary carbon. It is called a secondary carbon because it's attached to two other carbon atoms. This one is attached to one carbon atom. Is that okay? So because the carbon that when the carbon that is attached to the organogen is attached to only one carbon atom, that is the primary carbon. When the carbon is attached to two carbon atoms, it's called a secondary carbon. That is one way to remember it. And this effect will be less than the one felt by this guy. Now, so this is a tertiary carbon. Why? Because it's attached to what? Three other carbon. And you know that this tertiary carbon is not chiral. It's not chiral because it is the same group all through. So it is not chiral. But whether or not it is chiral, as far as the tertiary carbon, it's going to have a higher inductive effect than this. Now, so the degree of carbon affects that. And why is it so? Because these guys are known to be what? Plus I groups. So because they are plus I groups, they are going to donate more electron density. And because of that, the induced effect on these guys will be more. Induced effect will be more. Why? Because this carbon will induce on this guy, will induce on this guy, will induce on this guy. Unlike here where it will induce on only two, and here where it will induce on only one carbon. Is that okay? So that is why the effect is more on tertiary carbon and what? And than the secondary carbon. And the secondary is more than the primary carbon. And this is the basis of carbocation stability. I'm going to explain that in the next video. Now let's talk about the strength of the inductive effect. Now, what determines the strength of the inductive effect? What determines the strength of the inductive effect are basically these two: the distance away from the molecule and the electronegativity value of the electronegativity value of the organogen. That is what determines the strength of the inductive effect. And also, now this degree of carbon also determines it. Is that okay? So, but it depends on the substances that are attached, the components that are attached. So especially when the alkyl groups are attached in this form, the alkyl group donates our electron donating group. So because of that, they make the inductive effect greater in the chain. And this is all about it on inductive effect. Make sure you share this video with some of your friends that might need it. And in the next video, we're going to discuss the next effect that bond polarization causes, and that is the electromagnetic effect. See you in that video. Make sure you subscribe to this channel, please, and extend this video. Tell your friends to also subscribe to help the channel. God bless you.